So about a year ago, I wrote AIP82, which pretty much introduced event-driven scheduling in Airflow 3. And well, that's what we're going to talk about for the next 20-25 minutes. Right. So agenda. So we'll split it in 3 parts. We'll first look into the past, which is Airflow 2. And as shocking as it can be, we're going to see that event-driven scheduling was already in Airflow 2. So then we're going to look at the present and pretty much what did we add, what did we create. And then at last, we'll look into the future and what is missing, what kind of feature we need to add to make it even better. Past. So let's look at this DAG. This DAG is very simple. Besides the fact that assets in Airflow 2 was named datasets, this DAG is a Airflow 2 DAG. You can take it and run it in Airflow 2. So it's a very simple DAG. It's not schedule based on time, but it's schedule based on an asset, which means that this DAG is going to be triggered whenever the asset receives an event. So how in Airflow 2, how to send an event to an asset? In Airflow 2, you have 2 options. You can either do it through the API, or you can do it through another DAG. Now let's look at a more concrete example. Actually, this example might look familiar to you. It looks really familiar to the example I used in the keynote. So let's say you have you want to trigger a DAG whenever you receive a message in your Kafka topic. So in Airflow 2, this is the kind of implementation you will do to achieve that. So I'm not saying this is the one, it's just one of the implementation. So you will have a Kafka topic, and you will need a job that is like external to the Airflow environment. And this job will poll your Kafka topic and will check constantly whether there's a new message in your Kafka topic. And when there's one, your job will just use the Airflow API to send an event to your asset. And then because the asset receives an event, then your DAG is being scheduled. So as you can see, in Airflow 2, it's possible. You can do that, but it's not ideal. It's not perfect. The reason why it's not perfect is you need to have this external job that is pulling the Kafka topic and that is sending an API. And having this job is not ideal because first, it might be complicated. You need to maintain it. Not all your Airflow users have access to your cloud provider or any service you use to update this job. So we wanted to improve that. Airflow 3. So now let's look at the exact same DAG. I left some space. We'll fill out the space together. So let's take this DAG and let's try to build the feature together. So now I have this DAG. What I want to do is I want to monitor my Kafka topic. I want to check frequently whether there's a new message in my Kafka topic. To do that in Airflow, we have perfect components. That is the trigger. So the trigger is a async component in Airflow, which pulls an external resource. So here it's a Kafka topic. And it pulls this external resource to wait until it reaches a given state. Here the state is there's a new message in my Kafka topic. So here I have a trigger, message queue trigger, that is pulling my Kafka topic. And whenever this trigger detects there's a new message, it will fire an event. Now, ideally, I'd like to send this event to my assets. So how to do that? AssetWatcher. So that's pretty much what AIP82 created and defined. It has been created in Airflow 3. The goal of an AssetWatcher is to associate a trigger and an asset. So here in this example, again, you have this trigger that is pulling your Kafka topic. Whenever a message lands in your Kafka topic, your trigger will fire an event. And thanks to the AssetWatcher, this event is then sent to the asset, which then trigger the DAG. So another way to see it, to better understand it, is through this diagram. So you have your Kafka topic, you have your trigger that is pulling your Kafka topic constantly. And then you have your AssetWatcher that is associating the trigger and the asset. And whenever the trigger fires an event, so here, whenever a message lands in your Kafka topic, this event will be then sent to the assets, which then trigger the DAG. And well, again, pretty similar to the example you saw at the keynote. An asset is not limited to one AssetWatcher. You can associate multiple AssetWatcher to one asset. So here in this example, you have two. One that is listening to a Kafka topic, one that is listening to a SQS topic. So this DAG will be triggered whenever a message lands in your Kafka topic or in your SQS topic. So what is missing? So I don't know if you realize, but same for my keynote presentation or this talk, I've been talking only about queues, right? So I've only used example using Kafka topic, SQS topic, but it's event-driven scheduling, right? So the reason why I'm using queues is in Airflow 3 today, queues are the only option to do some event-driven scaling in Airflow 3. I know it's a bit disappointing. The reason why is because queues are special. Queues are you can consider queues are temporary storage, like waiting to be emptied. So checking whether a topic, a Kafka topic, SQS topic, checking whether there's a message in those topics is super, super easy. But if we take some different example, it might be more complicated than that. So let's look at this example. Very common one. So you have your data lake on your left, and you have your DAG on your right, and you want to trigger your DAG whenever this data lake is updated. So how to do that? So if we follow the same architecture that we've been seeing since the beginning of this talk, you have your data lake, you have your trigger that is checking, polling your data lake, whether this data lake has been updated. When your trigger detects your data lake has been updated, it will fire an event. Thanks to the AssetWatcher, the event will be sent to the asset, and then your DAG is being triggered. So what is complicated here? Well, here what is complicated is polling or checking whether data lake is updated is more complicated than just checking whether there's a message in your queue. So let's zoom in this part between the data lake and the trigger. So here is the question is, how can I check whether my data lake has been updated? Again, it's not as easy as checking, do I have a message in my queue? So one solution is to retrieve the last update time of your bucket or any storage layer you're using. So you retrieve this last update time, and then you use it to compare it with last time you checked. When I say you, is the trigger. So you retrieve this last update time from your data lake, and then you compare it with the last time you checked. And if it's more recent, then it means it has been updated. And if it's not more recent, well, it means it's not. It hasn't been updated, and you need to keep polling. So in case it's more recent, it's gonna fire an event. This event will be then sent to the assets, which then trigger the asset. Trigger the DAG, sorry. But is that it? So what happens if we just stop here? So let's say the trigger, so we retrieve the last update time, we compare it with last time we checked, it's more recent, so I send an event. But so what happens next time the trigger will do this check again? Well, it will do the same. It will retrieve the last update time. It will compare it with last time we checked, and it will keep saying yes. So we will keep firing events, and these events will keep scheduling the DAG. So what is missing here is we need to save this information. We need to save this information on when was the last time we checked. And that's very important. And today we don't have this mechanism. We don't have this mechanism to store a state or variable in a trigger. So to answer the question, what is missing? Well, the answer is a state store. We need to be able to get and set some information in trigger so that the different trigger execution can, again, save and read information between them. They can talk to each other. One trigger execution can store one information and the other can just retrieve it to do its own logic. In the previous example, this information was the last time you checked, the last time the trigger check. And today there's a AIP open, AIP 93, created by Jake Roach. It's solving this issue. It's creating a state store, an interface to be used in triggers. The IP is a work in progress. It has not been voted yet, so it's not guaranteed it's going to be part of Airflow. But as a personal opinion, I think it's a very good proposal, and it goes to the right direction. So actually, if you're interested, please read this RIP and give your opinion and feedback. But regardless of whether it's going to be this RIP or another proposal, we need what is for sure is we need this kind of mechanism so that we can have this kind of use case. Like for instance, the example I just showed you, which is triggering a DAG whenever a data lake is updated. Thank you.